So I just wanted to make a quick note here as we get into this next section. You may have thought it odd that when I'm putting these designs together for the final shape, that, well, right now with the first three, there's more one-handed controllers than two. And for video game controllers, we're thinking about two hands. And I thought I'd at least mention the reason for that is for the mouse controls, there's also this part. On these little touch screens, I'm going to try to set up swipe text, do swipe text with my left hand, and then mouse controls all with the right hand to replace the keyboard and input. That's kind of one of my favorite little hobbies, but that part's not a simplified example, so that's not making it in the videos. But that's what all the one-handed controller parts are about, to go with that. So I'm thinking, since the other part of that's not making the videos, for the videos I should probably do just a regular game controller shape. And when we order the PCB, probably going to order both shapes anyway. One for a two-handed device, one for a one-handed device. And that way I have a controller that works even if the other parts of that idea, the swipe touch screen, doesn't work out like I was planning. But again, that's not a simplified example, so that's not really making it in these videos. And now as we get ready to start putting this protocol together, and while doing that, I'm going to go ahead and make the first pass on the instructions that relate to the protocol and the documentation. Get that knocked out of the way at the same time. But as we put it together, we might want to make sure that we don't have any restrictions, or what restrictions we have as we put the protocol together. Which means we need to do a little bit of math here. So we're on a knockoff Arduino, so that means we have the Atmega 328 chip. So we can get up to 16 megahertz reliably. If we try to run it faster than 16 megahertz, we might lose some reliability from our pulse width modulation. But we're not using that in this project anyway, but I'll still use that as the upper limit. So 16 million bits can be moved every second. And for a game controller, 60 frames per second seems reasonable. So divide that by 60. And that's how many bits we can move every second. Whoops. Try to get where there's not a glare there. Okay. Had a light reflect, one of the lights reflecting on there. So we can move this many bits every second. And what do we have? We have the x-axis and y-axis, A, B, C, and D buttons. So we have 6 things that will be sending a number to the thing. And if we don't make any changes, those are all integers. So that by default in that the Arduino IDE, we're using 10-bit integers from the C family. So we have 10-bit, we're sending 6 10-bit numbers at every one of those frames of the game. So that minus the 60 bits we've already accounted for. And that's how many bits we can use in our protocol. So in this case, we're well under that limit, no restrictions or anything. I just wanted to be thorough in the process and include all the steps. So when we get ready to write a protocol, remember that is a step we want to check the math and make sure we don't have any restriction. We aren't restricted on our bits. In this case, we can still send lots of bits at every frame of the game. So I think we'll be okay just to work with strings, spelled out strings. We won't need to abbreviate anything. Won't have to simplify it to characters or come up with an integer scheme, something with less bits. We can just straight up use a string that has a meaningful representation of what we want it to do. And we will, I think, using Unicode strings, so 16 bits each, we can fit a lot of 16-bit characters in what we have left to send every frame of the game. So let's jump over to the computer and get started on that. Oh, and it's probably time to update the picture because we changed our labels, right? On that picture for the instruction manual, these are now called A, B, C, and D, so might as well go ahead and update that picture while we're at it. And with that number in mind, here's what I jotted down as idea for the protocol. So definitely want to get going to want to get the status, make sure we're connected at some point, and then a command to retrieve the value from each one of our controls. And these I haven't completely decided on, but I haven't ruled them out yet, so probably should include them in the math. So this is just some groupings. Get the X and Y axis together, or get all 4 buttons together. So kind of group the controls, and or send all 6 things at once. I haven't completely decided I'm going to do that, but I haven't ruled it out yet either, so I don't want to leave it out of the math. And the longest of the keywords is going to be 8 characters long, and that's Unicode, so 16 bits each. And we will send, well, the plan is to ask for each control, so we might be sending up to 6 commands, 6 of those at a time. So we'll take our number of bits and subtract 8 characters times 16 bits, and could have 6 of those words. So we are down to that many bits left for processing. So that's all our data that we'll need going back and forth. And we have this many bits left for processing. And when we get into the fetch, increment, execute cycle, well, we're going to get the words coming down to the serial port, which is going, so we're going to execute a fetch and then make a comparison and see if any of those words match the ones on the list. And if they do, then we will grab the value from the control and send it back, which is another fetch and then execute. So it looks like we're mostly going to be fetching execute instructions, so there's not a whole lot of processing going on. So I think we still have plenty of bits for processing. But if we wanted to, we could just subtract some extra, just to leave it out of there. If we're times where we're more worried, just get I don't think we'll even need 2,000 bits for that each time. But I'm going to go ahead and subtract a much bigger number. Go ahead and subtract 16,000 bits left for processing, which is way more than we'll need in this case. But so that's how many bits we have left over as far as our data is concerned, and a very rough estimate on the processing that we're going to do 60 times per second. But we also need to check our baud rate, the actual transfer rate as well. So in an earlier video, I set our baud rate up to 115,200. So that's how many bits per second we can get going down the line. And we're going to do that 60 times a second, so we need to divide by 60. And baud rate is oscillations per second, which works out very nicely with computer stuff, because usually we can just take those oscillations to be bits. And if we need more, there are some tricks we can use to hide more bits into a frequency. But I don't think we'll need any, because we'll have 19,200 bits each frame of the game for the controller aspect. And we're going to be transferring 60 for the value of our controls, 6 10-bit integers. So minus 60. And that's how many bits we have left to transfer for our protocol. And we just saw on the quick list, the longest instruction is 8 Unicode characters. So we'll take that minus 8 times 16, and we'll have up to 6 of them, because if we use these 6, we won't be using these, and if we do work in these groupings, we won't need all 6. So 6 is the upper limit. So we'll need 6 of them at a time. And yeah, we still have plenty of bits. Of bits available on our transfer rate. So looks like all the calculations are good on this case. This isn't very complicated, so I knew we're going to be well under that, but just to be thorough in these videos, going through all the steps, want to make sure and punch the math in the calculator, and or at least do some estimates and make sure that that everything is within our limitations. So now we're ready to start actually putting the protocol together. Okay, so to update the picture, I just found a scene in the video where it seemed to show the controller good. So I'm just going to take a screenshot from the video. Seemed an easy way to do that. So Windows Shift S to take a picture. Get a little picture of our controller. And from the message box now we can, notifications, we can go ahead and save this image. And then put some labels on it. So hit save. And documents in the basic control unit. In our documentation, the images. So this one will be actually be device. So we have a starting picture to work with. And then I'll just overwrite the device labels in Microsoft Paint or something, which is right behind my record button. So I have to pause the video to start Paint. So over here in Microsoft Paint, this will work to put some labels on here, which I have much better software to do this for the final version. So over here we have movement controls. Well, black doesn't seem the right color for that. But we're not to the final draft yet, so how's white look on there? White kind of shows up. Just make that a little bit bigger. Oh, not that much bigger. And we're not to the final draft yet. I have much better things to use for the better image editing software for the final draft. But for now, the intermediate steps, anything will be fine. And over here we have our action controls. And I'll just, will this work? I put an A there. Yeah, that looks like it fits on the button. Put a B there. Again, not the final version, but this seems like it'll work to get our labels on here. Might as well draw a little picture here. So we have horizontal axis as well as a vertical axis. And again, just including all the steps. So part of this is I'm just thinking about what this image needs to look like. Because now that I see those letters there, that's probably not going to work for the final draft, but it'll work for this draft. And our horizontal is called X, and our vertical is called Y. So all the labels are kind of trivial in this case, but we can see that things will be labeled. So now when we start to put the instructions together as we write our protocol to connect this control unit to our computer, we'll have an image to refer to, and we'll come back and do a much better one for a final draft and some better software than Microsoft Paint, but a quick, easy way to do it. And we can just go save as. And I'm going to keep this image around and then use device labels, which is already linked to in the, I guess I'll override that. It's already linked to in the web page documentation. So if we go in there and check that, index page. And under instruction manual. So there's our new image, and as we start writing the instructions, as we put our protocol together for both a mouse control or a game controller, we can set those up and refer to the labels in the images, which obviously there will be a much better image coming later. So let's get started putting that protocol together.